No, I looked at the math last period. They're different. All right, for the warm-up, you are graphing compound inequalities. So today, these are simple inequalities like what we did the other day. So here we're looking at inequalities. An inequality is a single comparison of a sentence. So x greater than 4 is an inequality. The symbol or inequality is this symbol right here. And then this is how we graph it. So the idea of the warm-up is getting an understanding of where is it open, where is it closed. So what we're going to do today is talk about compound inequalities. A compound inequality is a pair of inequalities joined together. So it's a pair of inequalities joined together, and they're joined together by the words and or the word or. So you have and inequalities and or inequalities. And inequalities are the intersection. And inequalities are the intersection. Or inequalities are the union. So and intersection or union. So if you look at a comparison of two graphs, the and share everything in this middle region, where the or are typically opposite. They're going in different directions. And problems must overlap. All right? Everybody still copying down? So what we're going to do is solve and graph, and you're going to do it exactly like we did the other day, except for now, what we're going to do is solve for each individually. So you add 1, or in this case, you will add 1 to both sides. So you get 2x is less than or equal to 3x plus 1. Subtract 3x from both sides. Divide by -1. When you divide by a negative, it changes the direction of the inequality. So we get x is greater than or equal to -1. And then over here, you're going to subtract 4x. Divide by -3. change the direction of the inequality, and you get x is less than 3. So we have x is greater than or equal to -1, and x is less than 3. So the solution is the overlap of both of those. So open circle at 3, shade right, close circle at -1, and then you shade to the right. Sorry, so the open on 3 was to the left, closed on -1 to the right. So where they overlap is your solution. So what that means is that x has to be less than 3 and greater than or equal to -1. And solutions can be written as a single inequality. Okay? Number 2, subtract x. So you get x is greater than 6, add 7, x is less than 9. So again, it's listed as an and, so they need to overlap. So we have 4, 5, 6, 7, 8, 9. Open at 9, open at 6, and shade between, because x is less than 9, but bigger than 6. Yes. Number 3. Subtract 9. Divide by 3. Over here, subtract 1. Divide by -2. And when you divide by a negative, your inequality changes direction. So I have x is less than -4. Open circle, shade left, open circle, shade right. So again, x is either less than -4 or greater than -2. And number 4, add 1, subtract 3, and again, x is less than 4 or greater than 5. Open at 5, shade above. Open at 4, shade below. Number 5, this doesn't have the words and or with it, but because it's one inequality, this is an and problem. And to isolate X in the middle, whatever you do on one side or to the middle, you're going to do to the outsides. So if I want to get rid of the plus 4, I'm going to subtract 4 from the left, the right, and the middle. So that gives negative 12 less than 2x less than 8. To get rid of times 2, we're going to divide everything by 2. And I get that x is less than 4, but greater than negative 6. So open at 4, open at 6, and shade between them. In 6, it's an OR, so we're just going to solve for x. Now, 15 is a closed circle and shade left. X less than negative 3 would be over here, and it would be an open circle shade left. But because this is an OR, it's just the more inclusive of the two. So you only have to graph the less than or equal to 15. If it was an AND, it would be the 3 open and then to the left. But because it's an OR, it's both. If it was an AND, it would just be 1. Okay, the worksheet on the next page, front and back, is your homework.